In this video, we're going to discuss how we can connect an area model to long division. Remember, an area model is something we use to show or to model how we multiply two factors. If you want to see a video on how we actually use area model for multiplication, jump back over to the YouTube channel and there are two there for you. One is a 2 by 1, so a 2-digit factor by a 1-digit, and the other one is a 2 by 2. So hop on over there and check that out before you watch the rest of this if you're still unsure about area models. For our first problem we're going to look at just a missing piece in our area model. So in this particular one, we don't know the side length or the second factor in the problem. 46 times something is 322. So what you need to do is you're going to think to yourself the basic facts. 4 times what, that's what would go up here, is equal to 28. So with basic facts, 4 times 7 would be 28, correct? So I know I'm going to have a digit 7 in this side length or the other factor, but I need to confirm. Is it a 7? Is it a 70? Or is it a 700? And we use that by looking at our place values. So 40 is 10 times bigger than 4. So my 28 needs to be 10 times bigger. So that's where we get the 280. We don't need to make any changes to that 7. We can also confirm this by saying, well, is 6 times 7 42? And that is correct. So now we look at this and we can say, well, 46 times 7 is 322, but it's also a division problem. 322 divided by 46 is 7. Well, let's take a look at our next. For our next one, we have a lot more missing pieces. So we want to think about this entire box right here, this entire area of this rectangle is 102. We know that a side length is 6, but we do not know the side length for this area model or for this rectangle. So we're going to break it into 2 parts or 3 parts that we can work with. So we want to think about some basic facts again. So we want to ask ourselves, 6 times what is close to 102? When we're getting started with this, we want to use basic facts. We don't want to use facts that cause us to have to do a lot of sidebar work. So a good way of thinking about this is our multiplication patterns, like times 10, times 100, times 1,000, or times 2, times 20, times 200, until we get close. So for this one, I recommend just using 10. 6 times 10 is 60. So this side length right here is 10 units, but we still have to find this bottom section right here. So I know that this top one had an area of 60, so how much is left? I find that difference, and I still have an area of that 102 rectangle of 42 left. So now we can ask ourselves again, 6 times what is really close to 42? 6 times 7. So this area is 42, and I have no more area to distribute. So now I have 2 side lengths here. From here to here was 10, from here to here was 7. So altogether, this side length is 17. So 6 times 17 was 102, or 102 divided by 6 is 17. Go back and hit pause and practice this if you need to. If not, let's keep going. We'll do a couple more in this video. All right, this one's getting a little bit harder. Well, maybe not. We want to break it down into, according to this model that's already made for us, we're going to break it into 3 pieces. So the entire area for this rectangle is 784. And I know that one of the side lengths from here to here is 7. But I'm going to break this up into 1, 2, 3 smaller chunks of math facts that I can work with easily. So we ask ourselves, 7 times what is close to 784? Well, hopefully we can see that that would be 100. 100 sevens is 700. So the area of just this red part of the rectangle is 700. But how much area do I still have to distribute? I find the difference is 84. And I can keep going on. So now I'm going to find this blue segment right here. How long is this part of the area model? So I want to ask myself, 7 times what is close to 84? Now, some students might be like, oh, well, that's 12. Well, it's this, it's that. That is fine. That's great if they are that comfortable. But if they aren't, they can just say 10 groups of 7. That's an easy number to work with mentally. And there's not a lot of regrouping that they have to do for their subtraction. So now I find the difference in 84 and 70, which is 14. So I have found 2 of the 3 segments. Last one, 7 times what is 14? Again, an easy math fact. I've got all of my 784 distributed to the 3 line segments. So I'm going to add these guys up, 100, 110, 112. And I'm going to write it both as a multiplication problem and a division. Okay? Woo, that's a lot to absorb. Let's try one more, and then we'll call it quits. Okay? So this time, my total area is 575. And this model that was provided for me shows that I'm going to break this into 1, 2, 3 individual areas to help me find this. So we know the side length from here to here is 5 because that is our divisor. That's what our side length is. So let's ask ourselves, 5 times what is close to 575? Yep, 100. So the area of this first section is 500, leaving me with 75 more that I need to distribute. So we go to the next section. Ask ourselves, 5 times what is close to 75? Don't try to get fancy. Just keep it simple. It would be 10. True? So now I have 25 more left to distribute. Last question. 5 times what is close to 25? 5. I have distributed all of my area in this problem. The 3 line segments that make up my area model side add up to be 115. All right, I hope this helps you. This is part 1 of possibly a 3-part series that we'll work through for our long division. Hope this is helpful.